Hello, my name is Jay Lee,
And my name is Isabella Villegas.
and today we are going to be talking about our experiment, which revolves around the identification of unknown organic compounds through various means. Giving a quick overview of our experiment, we started with two unknown organic samples, compound number 40 and compound number 16, and utilized three different techniques in order to determine what they were. We used combustion data, IR spectroscopy, and NMR spectroscopy. Combining all three pieces together gave us the identity of the compounds, compound 40 being 1,3-propendioic acid and compound 16 being acetophenone. Now, we all know that organic chemical compounds are generally difficult to tell apart or distinguish. They all like to share physical characteristics, whether it's visual appearances, reactivities, or others. It is very hard to identify these compounds, which usually only have atomic differences, which is important because chemistry is used in the outside world, such as research and medicine. By conducting this experiment, we wanted to reinforce the reliability and reinforce our understanding of these tests in order to ensure their widespread influence across all fields that involve the usage of chemical compounds.
All right, and the combustion data was obtained by burning our samples, analyzing the carbon dioxide and water products via filters. The FTIR spectrometer captured the IR absorbances via peaks, and the multinuclear spectrometer captured the C and H NMR signals. And as for the results, the combustion data gave us the molar ratios of hydrogen, oxygen, and carbon. Okay, let me zoom in real quick. For compound 40, there was a 1.33 H to 1.33 O to 1 carbon ratio, while for carbon 16, there was a 8 hydrogen to 1 oxygen to 8 carbon ratio. We use this ratio along with molecular weight to calculate the molecular formula of the compounds, C3H4O4 and C8H8O, respectively. Then we looked at the IR spectra. Figure 4 shows compound 40, which has some important peaks such as hydroxyl peak, carbonyl peak, and a carboxylic acid peak. For figure 5 shows compound 16's noticeable peaks such as the benzene overtones, carbonyl peak, and sp2 and sp3 hybridized CH peak. Our spectra is labeled to show you where it appears on the structures. And then finally, we looked at the NMR signals. There were two NMR spectra run, hydrogen NMR and carbon NMR. For compound number 40, there are two signals for each spectra, while compound 16 has three signals for each spectra.
For context, NMR signals are interpreted based on the number of signals and their shifts. Hydrogens and carbons that are closer to electronegative groups will have a more downfield signal. For compound 40, we have three carbons, but two signals, which implies symmetry, with one signal less downfield, which represents the carbon next to a carbon, and one signal much more downfield, which represents the carbonyl carbon attached to another oxygen. Using IR, we can determine that the carbonyl and hydroxyl groups form a carboxylic acid. The HNMR also supports the existence of a carboxylic acid through the heavily downshielded signal at 11.5 p.m. There are two equivalent hydrogens indicating two carboxylic acid groups. Finally, the less downfield signal represents the two equivalent methylene hydrogens.
For compound 16, there are a total of 8 carbons, but only 3 signals in the C-NMR spectrum. One is more upfield, which represents a methyl group. At 130 to 138 ppm, there are multiple peaks, which represents the 6 carbons of the benzene. And lastly, the peak furthest downfield represents the carbonyl carbon. With IR, the benzene overtones confirm the benzene determined from the NMR spectra. The sharp peak represents the carbonyl group. The sp2 hybridized CH group represents the double bonds from the benzene, and the sp3 hybridized CH group represents the methyl group. With HNMR, groups B and C imply a monosubstituted benzene, with a total of five hydrogens, while group A implies a methyl group attached to the carbonyl, creating a methyl ketone, as you can see here. Using these results, we were able to build a chemical structure of the compounds as shown in Figure 10 and 11.
In conclusion, these tests gave us important details such as the molecular formulas, functional groups, and locations of carbons and hydrogens. Compound 40 was a symmetric three-carbon chain with two carboxylic acids at the terminal ends, while compound 16 was a benzene ring with an attached methyl ketone.
Based on these structures, compound 40 was correctly identified as 1,3-propendioic acid and compound number 16 as acetophenone. The success of the experiment supports the importance of these techniques when identifying chemicals in real-life research. Thank you.
Thank you.